Hello class, in today's lesson we are going to cover section 1.3, which is called the properties of numbers. In today's lesson we will be learning about properties of equality, properties of addition, properties of multiplication, and algebraic properties. We're going to start with the properties of equalities. A lot of these you will think are pretty obvious, but we are just giving them their official mathematical names so that we can use them throughout the class. First one is substitution property. That says if a number is equal to another number, then you can plug the second number in the place of the first number. So for example, a lot of what we have in algebra is going to focus on variables. So if they tell us, for example, x is equal to 5, and you have the expression x plus 7, you can take the 5 and replace the x to get 5 plus 7 for a total of 12. So you can replace equal things within expressions. The reflexive property, one of my personal favorites, says that a number is equal to itself. Shocking information, but that's something that we have to be able to use throughout our mathematical education. So that would be saying 7 is equal to 7. Again, I know something super exciting and mind-blowing, but we just want to be able to put a name to it. The symmetric property says that you can flip-flop what's on either side of the equal sign. So for example, if A is equal to B, then B is also equal to A. So if we look at a mathematical expression of that, we've got 2 plus 3 is equal to 5, and 5 is equal to 2 plus 3. Again, simply saying that we can flip-flop what is on the left side and the right side of an equal sign. The last part is the transitive property. This says if A is equal to B and B is equal to C, then we can say that A is also equal to C. So for example, what this means is that if 2 plus 3 is equal to 5 and 5 is equal to 4 plus 1, then 2 plus 3 is equal to 4 plus 1, which is a true statement. So it just allows us to plug in information and switch out certain pieces of an equation as long as they're all equal. Next properties we have to talk about are properties of addition. Again, this is not going to be new information to you. We're just giving names to these ideas. The identity property is saying that if you take a number and add 0 to it, you're going to get the number back to itself. So that's why we call it the identity, because nothing about the number is changing. For example, 11 plus 0 still equals 11. The idea of the inverse is to be able to undo the number. So you have a number plus the negative of that number is going to get you 0. So for example, in that case, 12 plus negative 12 is equal to 0. More often you will see it written out as 12 minus 12 equals 0, because plus and negative is just subtraction. Same kind of properties apply with multiplication. So we've got our identity. Again, we're trying to make the number not change. In this case, in order to multiply and get the identity, we need to multiply by 1, because we know that any number times 1 is equal to itself. The inverse of multiplication, much like the inverse of addition, is going to give us the opposite operation. So for example, if I have a number times 1 over itself, it's going to give me that identity back of 1. So for example, 1/2, or excuse me, for example, we have 2 times 1/2, which is equal to 1. Much like the addition property, that multiplying by half is the same thing we know as dividing dividing by 2. So the inverse is just giving us that opposite operation. One extra property we have for multiplication is called the zero property. As you might guess, it involves 0, and it's simply saying that a number times 0 is always going to equal 0. So it doesn't matter what number you pick. We can pick 1,234, multiply it by 0, and you're still going to get an answer of 0. Last type of properties we're going to talk about is the algebraic properties. These are ones that will come into play a lot during our time this year in algebra. The first one is called the commutative property. And this is saying that you are allowed to rearrange numbers in addition and multiplication. So, for example, if I have a plus b plus c, I can switch that around to say a plus c plus b. Or if we're looking at it with the multiplication, a times b times c. Notice for multiplication, I just write the numbers next to each other. I do not need to have that times symbol in the middle of them. But I can still rearrange the order in which they are being multiplied. So for a numeric example, 2 plus 3 plus 4, which is 2 plus 3 is 5 plus 4 is 9, is the same thing as doing 2 plus 4 plus 3. 2 plus 4 is 6, plus 3 still gives us an answer of 9. Same thing works with multiplication. 2 times 3 is 6, times 4 is 24, which is the same thing as 2 times 4, which is 8, times 3, which still gives us the 24. The associative property is a similar idea, but instead of shifting the order of the numbers, we're going to shift the location of the parentheses. So if I have in parentheses a plus b plus c, I can shift those parentheses to a plus parentheses b plus c. Again, the same thing works with multiplication. So if I have a times b in parentheses times c, I can change that to a and then in parentheses b times c. Again, looking at a number example, we can do 2 plus 3 in parentheses plus 4. 2 plus 3 is 5, plus 4 is 9, and that is the same thing as 2 plus 3 plus 4. Solving parentheses first, we get 7, plus the 2 gets us back to the 9. Same things work with the multiplication. 2 times 3 gives us 6, times 4 gives us the 24, which is the same thing as 2 times, in parentheses, 3 plus 4 is 12, times 2 still gives us 24. So now that we've got the names for all of these properties, we're going to use them to help us simplify numerical expressions. So we have the expression 7 in parentheses 4 minus 3 minus 1 plus 5 times 1/5. So our goal here is to solve this problem and to be able to name the properties that we use. First thing the order of operations tells us to do is 4 minus 3. Since we are just replacing that with something it is equal to, it's going to be substitution. So 7 times 1 minus 1 plus 5 times 1/5. In order to get from 4 minus 3, to 1, we used substitution. So we would note that off to the side. The next thing that order of operations tells us to do is 7 times 1. 7 times 1 is the identity property of multiplication. So we get 7 minus 1 plus 5 times 1/5. And in that one, we use the identity property of multiplication. The next thing that we need to do according to order of operations is 5 times 1/5. Once we do that multiplication, we get an answer of 1. And that was using the inverse property of multiplication. 5 times 1/5 is using the inverse. Next, we need to do 7 minus 1, which gives us 6. That's using the substitution property again. That's just a normal operation. And the last thing we need to do is 6 plus 1 giving us 7, and that is also the substitution property. So I want you to take a minute, look through this problem, and figure out which 2 steps they are missing. Type your first answer and then your second answer. So the 2 properties that were missing, the first one was substitution. They gave that one to us. We did the 2 times 4. Then they used the inverse property. That was the 8 minus 8. Then we used the identity to do 1 times 3. And using the identity of addition to do 3 plus 0. The other thing they're going to ask you to do is to find the x and name the property used. So we got 2 plus 8 is equal to 8 plus x. That x, if you look at it, is going to have to equal 2. And there are actually 2 properties that we could use for this one. If you wanted to go with the properties of equality, you could say the symmetric property. Again, that is the one that allows us to say both sides of an equation are equal. The other one that you could do if you wanted to talk about the algebraic properties is the commutative property, which says that we can change the order of addition. This next one, if 3 plus 8 is equal to 11 and 4 plus x is equal to 11, then 3 plus 8 is equal to 4 plus x. So we know that we need this x to get us to 11. 4 plus 7 gives us 11. And this if-then property that we are using to solve this one is the algebraic property, or excuse me, not the algebraic property, the equality property that we call the transitive property. Take a minute, see if you can figure out what the x values are for these 2 problems and what property is used. So the first one gives us x equals 7. That's the reflexive property, saying that 2 things written out exactly the same are equal to each other. And the bottom one, that's the shifting of the parentheses. We get our x is equal to 2, and that is the associative property of algebra. If you have any questions about this video, please let me know when you get to class.